Equations can have symmetry. Here we see the graph of x squared, which has symmetry about the y-axis, and the graph of 1 over x, which has diagonal symmetry. The main types of symmetry are y-axis symmetry, mirror across the y-axis, x-axis symmetry, mirror across the x-axis, diagonal symmetry, mirror across the line y equals x, and origin symmetry, a half-turn, 180 degrees rotation around the origin. The benefits of finding symmetry in an equation are: we understand the equation better. It is easier to plot. It can be easier to solve. When we find a solution on one side, we can then say also, by symmetry, the mirrored value. We can often see symmetry visually, but to be really sure, we should check a simple fact. Is the equation unchanged when using symmetric values? How we do this depends on the type of symmetry. For symmetry with respect to the y-axis, check to see if the equation is the same when we replace x with minus x. Example: is y equals x squared symmetric about the y-axis? Try to replace x with minus x. Y equals minus x squared. Since minus x squared equals x squared, multiplying a negative times a negative gives a positive, there is no change. So y equals x squared is symmetric about the y-axis. For symmetry with respect to the x-axis, check to see if the equation is the same when we replace y with minus y. Example: is y equals x cubed symmetric about the x-axis? Try to replace y with minus y. Minus y equals x cubed. Now try to get the original equation. Try multiplying both sides by minus 1. Y equals minus x cubed. It is different. So y equals x cubed is not symmetric about the x-axis. Diagonal symmetry. Try swapping y and x, i.e., replace both y with x and x with y. Example: does y equals 1 over x have diagonal symmetry? Start with y equals 1 over x. Try swapping y and x. X equals 1 over y. Now rearrange that. Multiply both sides by y. xy equals 1. Then divide both sides by x. Y equals 1 over x. And we have the original equation. They are the same. So y equals 1 over x does have diagonal symmetry. Origin symmetry is when every part has a matching part, the same distance from the central point, but in the opposite direction. Check to see if the equation is the same when we replace both x with minus x and y with minus y. Example: does y equals 1 over x have origin symmetry? Start with y equals 1 over x. Replace x with minus x and y with minus y. Minus y equals 1 over minus x. Multiply both sides by minus 1. Y equals 1 over x. And we have the original equation. So y equals 1 over x does have origin symmetry. Amazing! Y equals 1 over x has both origin symmetry and diagonal symmetry. You can visit us at mathisfun.com.